In this video, I'm going to discuss some basic principles about acids and bases. So, for acids and bases, there are three accepted definitions for determining when you have an acid and when you have a base. One is the Bronsted-Lowry definition. What that says is that acids are H plus donors and bases are H plus acceptors. So these hydrogen ions. And now you will hear them referred to as protons as well. So if you hear proton donor, proton acceptor, that's exactly what it's saying. So now why is H plus referred to as proton? I'm just going to cover that real quick so there's no confusion. So hydrogen atom, a neutral hydrogen atom, it has a mass, an atomic number of 1, meaning it has one proton, and a mass number of 1 also, meaning the protons and neutrons add up to 1. And if it already has one proton, that means it has no neutrons. So if the nucleus of a hydrogen atom is just a single proton, and if it's a neutral atom, that means it has to have the same number of electrons, so it's a single proton surrounded by a single electron. That's a hydrogen atom. H plus means that it lost its electron, so that it's positively charged. So at that point, all that's left of that hydrogen atom is just a single proton. So that's why H plus ions are referred to as protons as well. Right? So the second definition for acids and bases is the Lewis definition. And that says that acids are electron pair acceptors and bases are electron pair donors. Now, you don't need to worry about this definition too much right now, but it will definitely come into play later on in the semester. And the last definition is the Arrhenius definition. And that says that acids increase the concentration of H plus in solution. So these square brackets, that means concentration. So it means you're talking about the concentration of whatever is inside of the square brackets. So the Arrhenius definition means that the amount of H plus increases in solution. And for bases increase the amount of OH minus ions in solution. Right? Now, acids and bases can be classified as either strong or weak. So what's the difference between them? It's the amount of dissociation. So if you recall, I said that if an ion is able to dissolve in water, it's going to dissociate entirely into its ions. Right? They fully dissociate. With acids and bases, sometimes they do, sometimes they fully dissociate, sometimes they only partially dissociate. So strong acids and bases see full dissociation. That means, let's say you have 1,000 molecules of your strong acid or base in solution. You can assume that all 1,000 of them break up into their ions when they dissolve in water. Weak acids and bases only see partial dissociation. So if you take 1,000 molecules, maybe only 400 will actually break up into ions and give off H plus or OH minus ions. The other 600 will stay as their non-ionic molecular form. Now, there are 7 strong acids and 7 strong bases that you need to know. I have those posted on Blackboard, so that's another thing. So you definitely want to know them pretty well, but again, you won't have to memorize because I will have them on Blackboard for you. So basically, if you see one of those 7 acids or one of those 7 bases that's strong, you can assume that, unless it says in the problem itself, you can assume that any other acid or base that you'll see is going to be weak. Right? So the majority of them are weak. Now, when you mix acids and bases, you get a reaction called a neutralization reaction. So what does that mean? What is being neutralized? Well, it's the pH. pH is a measure of the acidity or basicity of a solution. It's on a scale of 0 to 14, technically, you can go slightly beyond those limits, but those are only in rare extreme cases, and you won't encounter those in this course. A pH of 7 is exactly neutral. So that is something that has no acidity and no basicity of all. It's exactly neutral. Below that are acidic pHs, and above that are basic pHs. And basically, the further you go from away from 7, the more acidic or basic you get. So if you go up, you're getting more and more basic, and if you go down, you get more and more acidic. So a neutralization reaction is when you mix an acid and a base to cancel out the effects of acidity and basicity and give you a neutral solution. So a neutralization reaction will always be an acid reacting with a base to form water and a salt. Remember, when I say salt, I'm not necessarily referring to NaCl. I can be, that is a salt, but that's just one example of a salt, right? A salt is just any ionic compound. So how would you write out neutralization reactions? Well, let's use, I'll show you two examples. So this first one, I'm going to use probably both the most common strong base and the most common strong acid. So this is sodium hydroxide and hydrochloric acid. Now, what products are we going to form? Well, the acid is always going to be able to give off an H+. So this is the hydrogen that is given off as an H+ from our acid. And the base is going to give off an OH-. So you get this OH- given off. And those come together, the H and the OH come together, and that's where you get your water. So that's where we get the water product. Now, the salt. For the salt, you just take the remaining ions, whatever ions were paired with the H and the OH, and you just put those together. So you put those together. In this case, we do get NaCl. But again, it's only when we're mixing these two together. And that gives us our salt. So this would be the neutralization reaction for sodium hydroxide and hydrochloric acid. Let's do one more. Alright, so now I still have sodium hydroxide as my base, but now I've got acetic acid. Remember, that's what vinegar is made of. Vinegar is just dilute acetic acid. Now, don't get confused, because I know I mentioned that bases give off OH, and you might see that OH there and say, oh, that looks like a base too. But if you see this larger group, the COOH, in that order, written like that, that is always going to be an acid. Right? That's an acidic group. If you see this in a molecule, no matter what's before it, if you see this at the end of a molecule, that's always going to be an acid. And in fact, that is the hydrogen that's given off by the acid. So that hydrogen pairs with this OH to get your water. Remember, you just pair the remaining ions together as your salt, and you always put the positive ion first. So Na, CH3, COO. That's called sodium acetate, and that is your salt. And this is the neutralization reaction for acetic acid and sodium hydroxide.